the previous topic, we saw which are some of the advantages that can make the surface mining method a superior method compared to the underground mining. However, underground mining has its own advantages. And finally, the ultimate decision to mine from the surface or from underground comes down to the specific characteristics of the deposit. In particular, mineral deposits can occur in very different forms, and they may contain a very wide variety of minerals. In this topic, we will try to see which are the characteristics of the deposits that are more suited for surface mining. Generally, it's easy to think that mineral deposits that are already outcropping to the surface or lying at very shallow depth from the surface are easily extracted using a surface mining method. From the geological point of view, we have several mineral deposits that are in these conditions and that can be extracted completely from the surface. And we can find also some deposits for civil constructions. For civil construction, we can consider the deposits of sand, clays, gravel, rocks, and all the stones that are usually used for making the cement. Then we have placer deposits, where mineral grains are deposited from water in rivers and beaches, such as gold, tin, rutile, zircon, sapphire, and diamond. Then we have residual deposits, where valuable minerals have been concentrated through the leaching away of gangue minerals under tropical climatic conditions, so as to form iron and manganese oxides and nickel silicates and aluminium oxides. Phosphate deposits, such as from bones or bird feces. Sedimentary iron and manganese deposits from times in the distant geological past, when oxides of iron and manganese crystallized from sea water and were preserved as geological layers. Finally, we have deposits of coal, when they occur near the surface. All these deposits are generally mined at the surface. The total recovery of the mineral deposit, the grade control on the deposit, and the economy of scale are very significant in the choice of the mining method. This choice becomes even more important when the mineral deposit includes the extraction of lower grade minerals. For example, this is the case of extensive disseminated ore deposit of consistently lower grade, where the viability comes from exploiting the entire deposit using a large-scale operation, which, once established, can mine efficiently for many years, processing vast tonnage to get sustainable yields. Another example is given by ore deposits of inconsistent grade, where the rich veins or the mineable bodies are too difficult to map, too accurately targeted by underground operations. And it's here that surface mining affords the selectivity of what is processed and what is waste at the time of the mining. Examples of disseminated ore deposits are porphyry copper deposits formed by circulating metal-rich fluids in fractured igneous rocks, often resulting in a stockwork vein arrangement. These may be tens of millions to billions of tons in size and contain from 0.5 to 1% copper and possibly gold at a few parts per million. Examples of deposits of inconsistent grade include skarns, commonly formed when hot granites contact carbonate rocks, driving fluid flow and mineral alteration, leading to deposits of tungsten, molybdenum, or copper. Or epithermal gold deposits, where gold-rich hydrothermal fluids permeate an adjacent rock mass, producing localized mineralization in veins and fractured zones. for very deep deposits, much over 1 kilometer, the advantages of a surface mining technique are seldom great enough to make it a superior method in respect to underground mining method. And we will see that in more details in Module 4. In the next topic, we will see which are the main morphological characteristics for the deposits that can entirely be extracted using a surface mining method.